Hello friends, this is a video of YouTube series Data Science and Machine Learning, and in this series we are learning about the data science and machine learning, various machine learning algorithms. We are also implementing the machine learning algorithms. We will also be having some mini projects later on. So in this video we are going to see some of the mistakes we did in earlier programming assignments. Also we will see the new kind of the data sets which is readily available and how to use that. So let me go to our KNN classifier. So we have three versions. This is the second approach, this is the third approach, and in fact this code is available on the GitHub repository which was shown in the last video, that means the 9th video, where we made that repository private. But after that video and before starting this video, I made that repository public, so anybody can download that. The link or the name of the repository, you can have it in a 9th video. So what mistake we did while implementing the KNN classifier? So of course the third approach was nothing but this is this third approach. Okay, somewhat slow. So in a third approach we used the sklearn library. Okay, and in that there is no issue about that. But if we go back to our second approach where we wrote our own KNN classifiers algorithm, and that algorithm or that logic is mainly available in a KNN utils file. So what happened? Okay, so let me just first run this third one. Okay, and if we run this with the different values of KNN, let's say we will start with the 3, KNN is equal to 3, and let's run that. And it's a bit slow. Okay, so it has run and you can see we are getting 100%. I think when we used our approach that time also we were getting. Now if I made it 5, what happens? Okay, and again we got 100%. Fine. The KNN value in this case we can increase up to 10 only, because we have only 10 training samples. So let's not go to even the extreme of the 10, but we may restrict ourselves to 7 or 8. So let's find out, and you can see for the KNN is equal to 7 we got 80%. Okay, why it is reducing and why there is a chance to reduce the results when we are increasing KNN value, we will see later on. Okay, but here let's just see or compare the standard library with our own implementation. Now if we give a 7 here, or let's say here also now this is our version, our implementation. So if we give a 3, okay, so it gives 100%. Even if we give a 1, it may give 100%. Let's see what it gives. Yes, it is giving 100%. Let me increase it to 5. Again, this is our implementation, so it is giving 100%. Now let me have a 7 and let's see. Okay, again it is giving 100%, but this is what not expected, at least when we compare the standard one. Now here in a both the third approach and second approach, the data remains same. So why there is a difference? So there is a really either the standard library is wrong or our implementation is wrong. But the standard library normally most of the people uses and they didn't complain, and even if they complain, the owner of that library will improve that, correct that mistake, and that's why there is a very low probability that there will be a mistake in the standard libraries, which and mostly the popular standard library which most of the peoples are using. So let's be biased towards our implementation, and this one is taken from our implementation, that means KNN utils. So what is happening here, you know, the KNN means is nothing but the k nearest neighbor. Okay, so whenever the KNN value changes, the indices in a sorting, how many indices we have to pick up in a sorted indices, it is decided by the KNN, but here we fix that value, so it should be KNN. Okay, so let's save this, let's run this, and again run it for a 7, and we got a 60%. Okay, so here we got a 60%. So and then if we go for the 55, okay, it is 100%. Let's go for the 6. Okay, 100%. So 7 it reduces, and also there it reduces. Only the way it got reduced in a standard library, it got reduced to 80%, and in our implementation it got reduced to 60%, and that's what the difference is. But let's ignore that difference, and we assume that now we have corrected this one. Okay, we have corrected the mistake, and let me go to the repository. Okay, let me confirm whether this code is from the GitHub. Okay, GitHub code only, so this is our working directory, and let me just open, not this way, shift, first select, then press shift and right click and open in a PowerShell. So it will come to the path from where we open. Oops, it's taking time, so maybe what I will do, I will just close this. Okay, there may be another method. Let me type the CMD. And you can see even the CMD is open. If I type there CMD, it has opened to that path. Okay, machine learning videos. So I can go to GitHub. That was this is the folder. Okay, so we can go there, and now we can see but in a GitHub there is a data science. Okay, and now let me see the git status. So let me come here. Yeah, so git status. Okay, so 2-3 files we have changed. we have brought one more file also. We will see that. So git add dot git commit minus m for message, and message is knn mistake corrected. Okay, so we push this. So let me git push, and the branch name was main, so origin main. Okay, we could not resolve the git this one because there is a internet connection was down. Now if this is okay, so we can give that command, and you can see the earlier two commands were not affected because of internet down, but git push, because that need to connect to the global version of git, that means GitHub version. So here now it is going to push the new version, and that's how we could correct our mistake. And then this is also one of the reason that people prefer to use a standard standard open source libraries, mostly which are the popular and has been used by so many people over a implementation from the scratch. So normally people avoid the implementation from the scratch, and you can see that this was the one of the reason. Fine. Okay, so it has done, and we can check later on that whether okay, but now it is confirmed that it will keep on updating in a GitHub version also, so we don't have to see every time whether the change has happened on the web version or not. Fine, let's move on to the our next topic, which is a new kind of the data set. Now this is the data set which we have, and what it is all about. So this data set is actually of is a iris data set. Okay, so what is this data set? So if you go to the Google and search for this, I think this is very standard, and this link is under the scikit-learn, so this is very official information that this data set consists of three different types of irises: setosa, versicolor, and virginica, petal and sepal length. So irises, petal and sepal length stored in a 150 into 4. Okay, so we have a 150 I mean this is the one of the species of flower, and in that species I think there are the three different types of subspecies. One is the setosa, versicolor, virginica, and how to classify that, or what are the characteristics of each of the sub species is represented by their petal and sepal lengths. Okay, and also widths. So the rows being the samples and the columns being rows being a samples and columns being a save. So what are the columns are there? Sepal length, sepal width, petal length and petal width. Okay, so the below okay, so I think we are going to see about this, but what was important to understand is it has a 4 characteristic: the sepal length, sepal width, petal length and petal width. Okay, um, and then from these characteristics it can be classified, this iris species can be classified as either the setosa, versicolor or virginica. Now let's go back to our fine. So here you can see if you see this data set, okay, so let me just put this on the debug mode, and okay, here we have more libraries like a matplotlib pilot, pyplot as a plt. Then this is not useful at this moment, so even we can comment that. sklearn, which is scikit-learn, we have already seen in the last last video, last to last video. And then there is a 3D plot also. Okay, so if you see that let me, yes, and it has read the iris data set. Now what is this iris? Is nothing but is available here. So it is a one of the object they have created, and this object is nothing but it has a what is called the data, which is the data as a variable. Then it has a target. Yeah, so here you can see the data has some keys, and then that data is a numpy array. Okay, so main is this, and these are the 4 columns, and we have a 150 rows. This much is a, okay, 0 to 149 means 150. 150 into 4 dimensions data is associated with this. But what about targets? Now these are the targets. See, so this was the input kind of thing, and this is the targets, so output. So we can see 0 0 0 0 0 0 0 means 0 0 1 2. Okay, so what is this 0 1 2 target? What they have done, they have given the 0, they have enumerated setosa as a 0, versicolor as a 1 and virginica as a 2. Okay, so they have just enumerated the value for those categories, and those values are written here in a int, the array of int it is. Okay, fine. I think target names are there. Okay, so setosa means 0, 1 means versicolor and 2 means virginica, just now we saw. Okay, so that enumeration is also given. So this is the one object, and let's go. Now we know what is important from that is nothing but the target values and the data, that means the 4 by 150 array. So you know, iris data is taken from 0 and up to 3 columns. So we have taken a first 3 columns. Fine, we can take a 4th column also, but let us actually the first we are plotting the two features only, so actually it could have been 2 also, right? So first 2 columns of 150 samples will come here, but now we have changed that 2 to 3, and that's why first 3 columns of the 150 samples will come here, and all the 150 targets will come into Y, right? So you can see that it is coming as a X. X is a 150 into 3 dimension and 150. Okay, now we have calculated the minimum value and max value, because for the plotting, see what is the aim of this exercise is, if the data is given, we have to see we have to see how can it be classified. So how can we see the different classes, and how we can see the different features which are representing the each of the samples, and then we can take a decision. So once I think we start seeing at the features, once we will get to see the features, I think we can see that. Just the x minimum, x max, y minimum, y max, and z max. So 3 dimensions, but actually 2 dimension. In the first plot we are going to plot only 2 dimensions only, so you can ignore the third one. And then now this is, see, you can see x of 0, x of 0, and x of 1. Okay, because this is capital X. So capital X of 0, that means 0th column, and these are all the rows. The colon means all the rows, comma the specified column. Here also the all the rows, but specified column means first column. So 0th and first column, that means the two features we are plotting for all the 150 samples, and these are nothing but the sepal length and sepal width, and that is why X label and Y. So it is actually called the scatter plot. Let me see this. Okay, so what we will do, okay, fine, let us see, let us go ahead with this. And now it is going to plot, it is going to label y label, x lim, y lim, because you know minimum and max, so that we can, and then text. Okay, so let's see if plots has that. Okay, it doesn't have, because plot show is here. If I give a plot show here, okay, so it will run that and it will plot. Okay, so in between we can, and now I think here we are getting a one warning or one suggestion: figures now render in the plots panel. That means, okay, plots panel by default. Okay, so that's why it is showing in the plot. Okay, this is a variable explorer and this is the plots. So plots panel, to make them also appear in line in the console, means here. Okay, so most of the print output comes or get printed or get displayed on this console panel. Okay, so you can also do that. You can also do this plotting on this console, but next time we will do that. Okay, and they have given the suggestion that unmute the mute inline plotting under the plots panel option window. We will do that, but let's just go through this one. And okay, so this is the sepal width and sepal length, and three different classes. Okay, so 3 different classes, 3 different colors, right? So maybe I think in the next run, when the plots will displayed in a console, I think we will get to see that properly. Now just let us just go through the coding instructions, what it does. Now this is going to be another plot. Now in this plot, we have initialized the axis 3D graph and all, and then x0, here what we did, capital X of 0th column, capital X of first column. Okay, so only 2 features. Now here 3 features. See, what we can do, we can always see the 2 features on our paper. Okay, we can draw it. 3 features on paper also we cannot draw. Okay, but in a computer screen I think we can visualize. We can visualize properly because of the some elevation, and there are the so many different concept of the showing the 3D on the screen, and that's I think one of the factors like a kind of isometric projections and all. So with the help of that, we can feel, even though screen is a 2-dimensional plot only, which has a horizontal and vertical things, it doesn't have a depth. Okay, but because of the isometric projections, I think we will able to see even the 3rd dimension, or we will able to feel the 3rd dimension. Okay, so just hold on for some time, and I think we will get to see that 3 dimensions So we have already seen the 2 dimensions, and let's go for the third dimensions, 3 dimensions pictures. So sepal length, sepal width, it should have been sepal width actually. This should be on the sepal width. Okay, fine, no problem. Okay, so okay, so this is the third plot has come. Okay, so this plot, because now plot show has been already executed, and that's why second plot, which is the 3D plot. Okay, so let's run this again, because this is very interesting to see, and this time we are going to do as the console panel instructions suggested. So what we are going to do, the mute inline plotting, what it is saying, uncheck. So we will just, because this is the unchecked, but this is okay, this is the unchecked, but this is not unchecked, so this is checked one, so this is unchecked. Now you can see this is unchecked. Okay, and now I'm going to run this. Let me have this variable explorer, because the plots are going to be there also, and plots are going to be on the console also. So let me just run this, and you can see the, because this time it was not debug. So yeah, so first graph is a between sepal width and sepal length, and you can see the red ones are very good to very separated on that 2 features plot. Okay, scatter plot. The gray one and yellow one are somewhat mixed, and there it is going to be a challenge if only 2 dimensions to be considered. Okay, but okay, what happens if we add the third dimensions? So we can see this is the third dimensions is added, so red is completely away from the this 2, and now depending on the this height of the yellows, and depending on the height of the this gray one, we might or might not able to separate these 2 classes in some points. Okay, because separate is what we will come to that. Okay, in fact the after in the next video, the first topic or first thing we are going to touch on is nothing but the separability, right? So at this moment, let us just observe the data, and here the main objective of this exercise was to display the data in a 2D, in a 3D, in a 4D. No, we can't do that. Even computer screens cannot do that. Okay, so so how to assume that 4 dimensions and all, I think we will see that it is very computational extensive topics, and we are going to see very soon. But right now at this moment, you can see these are the 3-dimensional graphics or 3-dimensional graph, and where we can easily see the classes corresponding to the 3 dimensions, and we can observe whether they are separable or not separate, or the classes are different or not. Okay, or there is a overlapping. So here I think the red one is very good separable. Okay, separated from these 2, but in these 2 classes there are some overlaps you can see in between, which might create a issue in a classification problem, and that will and that will be the reason that we might not get 100% classification. Okay, theoretically, by just observing the 3 dimensions. We haven't observed the 4th dimension. Okay, so let's not bother about that, but whatever the 3 dimension is showing, let's conclude for time being that okay, the gray classes and yellow classes may create a problem of misclassification, and red is going to be classified very properly. Okay, just by observation we can conclude this, and this was all about for this